Hello everyone. Wanted to explain the arithmetic coding process through an example. Um, so in that example, we have a probability distribution of a source represented by four symbols: A0, A1, A2, A3, or A4. And they're given the following probabilities: A0 55%, A1 15%, A2 15%, A3 10%, A4 5%. Okay, so I'm going to divide the interval from 0 to 1, which represents the entire probability space, according to the following distribution: 5, 10, 15, 15, and 55%. So from 0 to 55%, we have the space occupied by A0. So this is 0.55. And then from 0.55 to 7.7, we have the space occupied by A1, and then another 15%, we have 0.85. We have the space for A2, and then 0.95. We have the space occupied by A3, and then this small sliver is for A4. All right, so I'm going to assume that we have a message to be communicated, which is A0, A2, A1, A3. All right, so this is the message that we want to send on the sender side, and I want to find a binary sequence that represents this message through the arithmetic coding process. So the way we go about this is by first looking at the first symbol. The first symbol probability is 55%. So we are clearly in this part of the 0 to 1 interval. So the arithmetic coding basically takes that interval and imagine that we are living in that interval and remaps it, or consider that we are living into, instead of this interval being from 0 to 55%, imagine that this is becoming the entire probability space. So as if it's from 0 to 100%. So the upper limit and the lower limit are still from 0 to 0.55. However, we think of it as from 0 to 100%. And then we're going to map or remap these probabilities onto this interval. So projecting these probabilities into the probability space from 0 to 0.55. In other words, 55% of this probability space is occupied by A0, and then the next 15% by A1, next 15% by A2, 10% by A3, 5% by A4. So it's not very hard to tell that the starting point will be this point, and then you need to do some sort of shifting and rescaling. And the formula for this is in the article. So for example, here, the starting point for A00, so I'm going to divide this into A00, the space occupied by A00. In other words, this represents what would be the interval if the message would be A0 followed by A0. So this would be basically 0, which is the start of this interval, plus the range. The range is from 0 to 0.55. So 0.55 minus 0, that's the range, and scale it by this amount, which is 55%, which is the probability of the A0. So 0.55. and that gives us the, that gives us the upper limit here. And then similarly, we can go ahead and calculate the interval for A0, A1, and then A0, A2, A0, A3, and A0, A4. All right. So that gives us the redistribution or the mapping of these probability distribution over that interval. So we keep basically narrowing down the interval, the original interval, or refining the original interval based on these symbols. So first symbol is A0, but then it's followed by A2. So we're not going to take this this interval, we're going to pick this second interval basically, because the message is A0, A2. So we need to find this lower limit and this upper limit. All right, and this becomes the new interval then we need to refine. So we take that interval and imagine that this is the new probability space. This is the new 0 to 100%, and then we take all these probabilities and project them onto this interval. So the first 55% of that interval becomes the space in which A0 lives, and then the next 15% the space in which A1 lives, and so on. So I'm gonna expand this like this, right? The lower boundary here you need to figure this out, and it's easy. So let's do this calculation. The lower bound here is this lower bound, which is 0 plus the range, which is 0.55 minus 0, times what is the lower bound here and the lower bound here. I'm sorry, what is the what is the start of this interval? Here is 0.7, and the end of this interval is 0.85 in the first mapping. So point multiplied by 0.7, and then in the end here is again the upper 0 plus 0.55 minus 0 multiplied by 0.85. So that gives us the lower and the upper range of that interval. So that interval here is the new interval, and I'm going to project these probability distributions into that interval. Again, the first 50% will be for A0, so that gives me A0, A2 is where I started here, and then the first compartment will be A0, A2, A0, and then A0, A2, A1, and then A0, A2, A2, and then A0, A2, A3, and then A0, A2, A4. Make this a little bit taller. A0, A2, A1, A2, A3, A0, A2, A4. Apologies for the horrible drawing. So we end up with A0, A2, A1. So this is the interval we're interested in, A0, A2, A1. Now we need to do the same thing, figure out the lower and the upper bounds. And we need to, that becomes the new interval. Then we need to think of as the 0 to 100%, and then we need to project these probabilities into that new interval and do this over and over and over again until we get to the final range, the most refined range that represents this probability, this sequence. So this is the idea of the arithmetic encoding. If we do this carefully, we'll find that the final range that represents A0, A2, A1, A3 is between 0.4408, the lower range is, the lower limit is 0.44089, and the upper is 0.44213. So basically we started here with A0 from 0 to 0.5, and we ended up, after the incorporation of A2, A1, A3, we ended up with this refined interval from 0.44089 to 0.44, such a very tiny interval that depends on basically the probability of the individual symbols. Right? Now our task is to find a binary sequence that fits completely within that interval. So I'm going to erase the board and go through the procedure that shows you how do we actually find a binary sequence that lives within that, or fits perfectly within that tiny interval.